Hello everyone. So I'm starting with my diabetes prediction ML project right now. So let's see, I've made a video on this. This video includes some PPT presentation and also the Jupyter notebook where I have just made that ML project. Let's see how does it work. So this whole of the video includes introduction and problem statement, like what is the problem we have and how we can solve that problem. Data information is a very important slide, I think so, because it contains the how the information we have and what we have done with the information. So this is also included in data manipulation, and then we discuss about model development and training and also metrics, like we how we develop the training and what kind of metrics we got. Then we will see about web interface. Actually, it should be a website or something, a web page where the user will input all the data and will have to get the desired output or the classification. But let's see how it will work out. I've just given an idea how that can work actually. So what in the next slide I discuss about what are my future plans or how we can make a better output of this project. And then after that we'll look at Jupyter notebook, how will it work. So let's go to the next slide. So here's some introduction, like some data, historical data we have. So 537 million adults have diabetes, which is 1 in 10 people. I'm sure that whoever is watching this video, they must have anyone in their relation or in their like family who has not a very close family, but someone must have heard about this diabetes in their whole back-to-back families. And it is just predicted that 2045 this diabetes cases will grow to this much amount. So here's a little bit description. So how diabetes is a major cause of blindness, kidney failure, heart attacks, stroke, and lower limb amputation. High blood pressure, sugar levels can damage blood vessels, leading to these serious complications over the time. Just managing diabetes through medication, diet, these can reduce the risk of these complications. So we'll go to the next slide. So what we have the problem statement right now. So we need to develop a machine learning model to predict the likelihood of a person having diabetes based on certain health metrics, or we have some data, some parameters of the health medical output test that had been done on the patients and demographic information. The model should take into account some features as age, that is BMI, that is body mass index, blood pressure, and other relevant factors to make accurate predictions. So, like, yes, this is the data set that is I have downloaded from the Google, but there are many factors that can affect the onset of diabetes. So, a particular domain expert or someone in that domain will can give a better knowledge on that. But still, I'm trying to make a better output of this whatever data I have. The goal is to provide the healthcare providers with a tool that can assist in early identification and management of diabetes. So what is the solution? See, there are a lot of people who already the data have been taken from them. So we have historical data. So if we have historical data, then we can take this condition that we have. So we can use supervised machine learning here. Main point to be noted here: the patient will either have a diabetes or not have a diabetes. So we can classify into two classes, as it has two classes. So it is a binary classification problem. Some of the models that we can use here are logistic regressions and deep neural network classification. So we can use Credala's sequential models to create different deep layers on that. Then we can also use support vector machines classification and decision trees also. But today in this video, I want to tell you in previous that we will be using SVM, that is support vector machines, and only one kernel. So we'll talk about later. What is the data we have right now? So we have a CSV file containing 768 rows of data and 768 patients. Total number of features, our total number of parameters for each and every patient is 8, and one is a target label. So here are the things. Pregnancy is the number of times the woman is pregnant. So yeah, it is not written here, but it is actually the whole of the data is coming for all the women, I think so. Yes. Then what's the glucose level, the blood pressure, the skin thickness, insulin, BMI, diverse pedigree function. So it is kind of a diabetes pedigree function. I did a research on this. So it is a function that has a specific value between 0.08 or 0.8 to 2 point something. So that gives me an idea that the person will be affected by that the diabetes or not. So it is a function kind of thing. And this is age, and this outcome, that is the class variable or label column. Now, to be as I looked at all the data, we have no null values in it, and I did this describe. So we uses percentiles. As you can see, that three columns in this whole data set has a very different kind of distribution. So those are this. This is no, all these things are good, but yes, you can see skin thickness after 51 it went to directly 99. So this something I'm not acceptable right now. See, many people have different kind of thinking with this. They can also use this or not, but I'll try to just. It is a very high data, so I just clipped. As if you will see in future, I clipped it. And same with insulin because 519 99% and then maximum 846. So it's kind of a outlier for me for my imputation. And then also you can see one more I did. Yeah, pregnancy. So I don't think so that the 17 pregnancies a woman can have. Yeah, I know 13 is also very large, but still we can avoid 17. Like let's be 13. So applied clipping in three columns after splitting. Where I did minimum max scaling. So it makes all the data between 0 to 1, something like that. Now we see next slide, model development, training, and evaluation. So I using a support vector machines classifier here and imported SVC from sklearn SVM. So support vector machines can also do regression and classification problems both. So I just for this classification problem I imported SVC, and after that for metrics or looking how the evaluation of the my machine learning model, I imported accuracy score, then trained SVC model with linear kernels, found accuracy store on training dataset, and then accuracy dataset. Next, how we can make a web interface. So I have made some like interfaces of different apps, one or two, but I have an idea how to make a Flask app or HTML CSS app, but I have not made this for this particular project. So I'm just adding this in my PPT. Make HTML CSS website form and add appropriate tags. Create Flask app and create an API routing to extract the input data from the form. Then you can run an ML model code, return the result to end user. So I've also written that interface will be done in this future videos. Future plans. So currently accuracy I got is 77%, and then accuracy on testing data is 75%. In future we'll train SVC with different kernels and will look for better accuracy. We'll make neural network classification on different kernels in SVM. Will make interface and use best models for prediction. Provide model to professionals to use and prevent the onset of diabetes. See, diabetes and medical industry is very huge, so we can use this. Hey doctor, thank you. So now let's we will go to our this where I have written this code in Jupyter notebook. I have told you everything, so I just imported NumPy, Pandas, Matplotlib. So we'll be doing some visualizations. So I just imported this Matplotlib, and then we will just do some training tests, split and SNS. I just download all these things because it is already written there. Downloaded it, and we have SVM. Then import accuracy score. We did diabetes. We imported this diabetes CSV file, and after it looked at some info that we have 768 rows, no null values, or integer or float, something like that. We did some this described. Yeah, so I plotted this diabetes pregnancies plot histogram plot. So what I saw that we have very little amount of people at a very high range. So And same when thickness, very high, around 99 something, very less amount of people are there. Same with insulin. So just try to clip all these things with just whatever my intuition said. And then after that, saw again two different columns, described it. Now the pregnancies column, all these things, pretty good. So now when I did this, now I had a thinking like this is kind of a normal distribution, not just there. Only one has some kind of normal distribution, but also, but I didn't do anything because I didn't know like what should do. I learn more. Will try to do more things. Now will I did some this y is equal to diabetes that pop and x is equal to diabetes. So look out train x and y both are differently splitted the data here. So I have my training and test set separately. Instant just initialized make it a instant of this min max scalar and fit transformed x train, then classify svm dot svc linear kernel I use here, then fitted my training data on that. Now we'll look at model evaluation something. So accuracy score is this classifier dot predict x train and training data accuracy is x train prediction y train. Then we have I wrote 77 now it is, so it is 78 here. And then I did this on X test, so got around 75. Yeah, so here how we can use this model at the end for web interface. So in the web interface, as I told that we'll be doing some API routing thing, then we can extract the data from the form. After extracting the data, we can make an array and just convert in that array to and scalar dot transform will do then predict, and this kind of output we can expect here. So yeah, this kind of this is the whole notebook I have right now, and I hope like you liked it. Thank you. This is a great project, I think so, because I did it everything from starting to end, and we'll try to do better and better projects again and again. So thank you. Bye.